Okay, so this is problem 610, and read the problem first because I'm not going to explain it. And so this is what I'm going to be going over. If you want to pause the video right here, go ahead, but I will work this out step by step. Alright, so this first problem is just conservation of energy. And so the clay is falling at distance h, and the pan really doesn't matter. So ui plus ki is equal to uf plus kf. So you only have this in the starting and you only have this in the end. So it's mgh is equal to 1/2 mv squared. Cancel out your m's, carry over the 2, divided by root your answer, you get 2gh is equal to v. The second problem is conservation of momentum, so you want to use MIVI, or MV initial is equal to MV final. Alright, so because the mass of the pan is capital M and the mass of the clay is also capital M, your final mass is 2m. And then your V initial is this velocity right here. So your VI, and then your initial m is just your clay, so it's just going to be 1m. And then your VF is what you're trying to solve for. So you see how your m's cancel out? You get VI over 2 is equal to VF. So that's going to be root 2gh over 2 is equal to velocity final. So for C, you're trying to find the period. Yeah. So this equation is directly from your equation sheet. So T is equal to 2 pi root m over k. And this m is the mass of the pan and the mass of the clay, so it's going to be 2m. And this k is what we need to solve for down here. So you know that at maximum stretch length the system is not moving. So this equation becomes true because the forces in the up direction cancel out the forces in the down direction. So it's kd is equal to mg. So k is equal to mg over distance. So you just want to plug this back into your t equation. You get t is equal to 2 pi root 2m, 2 capital M, over mg times d. So your m's cancel out, you get t is equal to 2 pi root 2d over g. And yeah. So for problem number D, that's a D. So again, at maximum stretch length, this equation is true because the forces in the positive direction cancel out mg. So it's kx, so x is the distance it stretches, is equal to m total g. Okay, so your x is the distance from equilibrium, and then your mass total is still 2m. And so your x in this case would be 2d. 2d times k is equal to m total times g. Alright, so you see how... Oh, wait. Oh, you're trying to solve for your x. Oops, I got a little bit ahead of myself. Ignore that. This is x, right? So, and then just ignore that. I'll show you the shortcut later, actually. So x is equal to 2mg over k. So your k from earlier is k is equal to mg over d. And so your x is equal to 2mg over mg times d. So you get 2d as your equilibrium. As your distance stretched from equilibrium. And there's actually another easier way that I actually skipped ahead to earlier. So you know that just the pan itself, this equation is true because it's at rest. But when you add on the clay, it doubles the mass, so it's going to double the distance then. And then boom, you get 2d as your answer, right? So for E, the oscillation period will be less simple because there's less mass on the system, as it will be just a pan, right? Because the rubber the rubber ball just bounces off, it doesn't stick with the system. So your T is equal to 2 pi root m over k. So when this decreases, because your rubber ball isn't sticking to the pan, this will also decrease. Down, down. Yep, that's a problem.